Hey, what's up folks? How's it going? It's your guy Ivan here, and in this video we're gonna be starting our probably several part videos on how do you get to train your own YOLO models, YOLO version 3, which is important models. And as you can see on this video, this is the model that I've trained about an hour or two ago on Google Colab with text open and close bus doors. And I've tried to do that before, but this time I've really got some outstanding accuracy, I would say, especially compared to my previous results. So how was I able to do that, aside from what's the essence of training YOLO version 3 to detect your custom objects? Well, I'm glad you asked. You basically need three things. You need to get the training data itself. You gotta get the pictures, whether you wanna detect headphones or notebooks or whatever is your spiel here. You gotta get lots and lots of images of it. Then you gotta label them, aka draw those bounding boxes, draw those rectangles in a way that with the annotation files that y'all will be able to read, and will be able to basically use that as labels and then train it on. And third part is a little bit rigorous, although all of them are kind of rigorous, but that one is when we actually throw all the files around, put everything in the right folders, prepare the object.data files, names and all that stuff. In this video, I'm gonna walk you through all of that stuff because it was quite painful to get all from the start. So I'm gonna try to do my best to kind of give the easiest way out for you that I can. And in this video, we'll be focusing on how to collect images. So for instance, this model was trained on about 2,000 images from Google, most of them. There we go, there's a bunch of bus images from Google, some noise images, and then a bunch of high resolution Google images from Google as well. And the special part of it was that I walked out on the streets when I was getting back from my school and actually went and took some videos of the buses, and that's so invaluable instrument when it comes to getting object detection, because if you take a video of your object, you get so many angles, so many different variations of the object in space that will help tremendously in the goal of the model to generalize well and get you the result that you want, which are probably good results. So took a bunch of videos and used software to extract the frame from them, then manually labeled that and got it all going. So in this video we'll be focusing on the first step, which is get the training images. I'm gonna show you how you can build a script in Python to nicely download a bunch of images from Google in high resolution. I've learned probably the hard way that high res is best, and also my friend John advised me that, so super excited to share that with you. And then I'm gonna show you how you can extract frames from the videos and use that as your training data. So guys, without further ado, I hope that you're excited. Now let's get started. So, alright my beautiful AI wizards, I hope that you have your Python editor by your side. You have a cup of tea or a water or whatever it is that you prefer by your side, because now we're about to do some serious web scraping to get the images. So let me tell you about the few ways that you can kind of get the images. So the first one that I was using was within browser extension, and it was the FATCAN extension that would basically download all the images from here, but the problem was that it would download them in like this low resolution. So like not like the full, for instance, in this case, like 1200 by 800, but only like just, you know, whatever it is, the resolution here. So I've came searching like for ways from where can I get here the like the URL to the full, you know, the full resolution of the image, because resolution is important. Even though in training, your YOLO will shrink your input to 416 by 416, it kind of makes sense that if you're gonna be trying to test that like in some shape or form in real time, you're not probably gonna be using camera with like 200 by 200 resolution or like something like that. So it kind of makes sense to start training your YOLO version 3 model with like images of better resolution. So I came to the source code. For those who are not familiar with like web scraping and all that, I've basically opened like the HTML, and it's basically got like all the like boxes for each guy here. So it's basically in HTML it's got like all those boxes for each image that contain all of the important information for us. And you know, to be honest, I've got pretty excited when I first looked at it, because like I looked at this URL, like that was a URL that I would have to like click again, and it would take me here, and here I would be able to like, get the full res, but it wouldn't be like that neat. So I would like have to automate the browser to like go and open new tabs and all that. Then here I would find like the small version of the image, and that's also not what we're like looking for here. And where I found the link was like actually in the place that I probably expected the least. So here's like this weird, some sort of Python looking dictionary, and here in just like by the name of OU, here's like that link that if we follow would get us to the image. Yep, there we go. And like from here we can basically use your URL lib to just download it and put it in the folder that we would like. But like, what do we know from here? Like, our task here is to basically download the like HTML of the page, and just find that tag with like that weird dictionary and pick up the OU, pick up like the value of OU element there. So it doesn't sound that hard. Actually, like it's like 2 lines of code, I think, to web scrap it, and not much more lines of code to get it all going. So like there's a problem that we face when we load the page not from our browser, which is that we'll only be able to web scrap just 100 results. And like, what if we want to actually go deeper than that and get, you know, I think I web scrap, like I searched for the name, like for buses and for the bus stops for my model, and I think I've downloaded like 100 from buses and like 400 images from bus stops. So like you oftentimes want to get more, and for that we're gonna use Selenium, which is a library that lets you basically open up an automated browser, but it's not automated. Like we'll basically be able to open up that browser and use it to kind of scroll down for as much as we like feel we need, and then get the page source, and you know, like then get the page source and basically use Beautiful Soup to pick up all the like all the tags that we need, all the data from them. And then I found out that there's a beautiful Python library called AST that basically lets you convert a string of a dictionary to like a usable Python dictionary, so it's not gonna be all that messy string formatting that I was being afraid of when I was starting out. So let's get started. What we're gonna need here is OS to save stuff to folders and all that. URL lib.request has ulib to download the images, from those URLs that we'll get. Beautiful soup imported as soup to basically pretty neatly and nicely parse through the HTML and like get all the data that we want. Like if you're not familiar with beautiful soup, like fear this not, like 2 lines of code tops, and ask to kind of convert that string dictionary to the real one. So let's get started. I have like that script written here, so here we go. We're first of all gonna need to from Selenium. If you want to install all that stuff, it's just pip install Selenium or like whatever you use. From Selenium import WebDriver, and here's something that I want to copy from here. And this is the Chrome driver. So Selenium was written for Firefox, so in order to open the browser in Chrome, you gotta have like that driver. I'll leave a link for it, like don't worry. I'll just holy cow. Yep. Just copy that path, and now we can like create the driver object, which will be driver WebDriver will equal to WebDriver.chrome, and here we put the link to the browser Chrome path. Now we can go ahead and launch it and see what will happen, guys. Magic. Let's check it out. We're opening up our browser. No, we're not, because I screwed something up. And now there we go. The thing should pop up. It's gonna do that. Let it take its time. There we go. Here's the automated browser. So you can see it's like says here that it's controlled by the automated software. So yep. And you can use we're gonna use then we're then we'll define a variable for our URL, and we'll just go to the Google Images, copy this thing, put this thing here, done. That is it. Now let's define 2 functions. The first one will open up the Selenium automated web browser and get all the URLs, and the second one will download them. Both will be extremely simple and quick. So we'll define get URLs, and here we'll be basically asking for the URL. So first thing we want to do here is to say that, hey, take our driver and open our wanted URL with it. So then it'll open the URL, and then we want to do something like say a equals input. We're not gonna use input, it's just a really non-fancy way to pause the program to give us kind of the time to scroll down. And once we did that, we'll say that page will equal to driver.pageSource, which will basically give us all the HTML that we need. Let's print page just to see kind of what's happening here. We'll call get URLs, we'll give it our URL, and let's launch this thing. Now as you may have guessed, browser will automatically go that URL, and then it'll automatically take over the world. I'm kidding. It's also unfortunately not gonna do the rest of the coding for us, so we gotta take on the challenge, and I'm feeling like we're here are capable of doing that. More than. Okay, so we'll open up the browser first, then we'll wait till it's loaded the page, and then we'll give it the input, and then it'll print out a bunch of HTML. So guys, that's it. Thanks for watching. Now you kind of go here and write things down. No, I'm kidding. Do not go from here. I'm not insane. Like, no, we're not gonna be dealing with that. However, what we will be dealing with is creating the soup object, which will come from a beautiful soup function that will allow us to parse the HTML, and will create a nice, like, searchable for the text and the classes and like all the elements of them, and that's what we need here. I'll create that, kind of parse the HTML that we'll be able to look at. So we'll create the soup, then we'll say that. Like, remember what we're looking for here. So basically, when I'll download the HTML, we'll have all like this stuff here, and just let me refresh the page because we've scrolled down quite a bit. So, okay guys, there we have it. So remember what we were looking for. We were looking for the div class, the div tag with the class of RG meta not translate. So we can like go and copy this thing. Now we'll say like, hey, let's call them desired URLs. We'll equal to find all. We'll equal to so find all. And here we say that we're looking for the div tag, and we want our class to be equal to this. So yep, it's gonna find that, and what we'll have is basically like this dictionary for each image like on this page. And once we've done that, like, it makes sense, we want to run some sort of cycle on all of them and extract our desired URL here, and like append it to some sort of list. So that's what we're really gonna do. We're gonna say that let's call it like our URLs be an empty list for now. Then we'll run a cycle. We'll say that for URL in desired URLs. Now, you gotta remember that when we're gonna like do the cycle, like it'll output like the tag itself, right? And what we want from the tag is the string, like it's the text. So on each of that URL objects, for us to like get the not tag, get the like the URL, what we're gonna need is take that URL, convert that to text, and we'll say that the URL will equal to, just let me remind myself the correct command, literal evolve. Okay, literal. So I mean, let's kind of check out what we have here. So we'll say print out the URL, so that it's kind of clear what's happening here. It's gonna launch the browser, then it's gonna, we're basically telling it, launch the browser, then wait till we pass you some input. Then once we did that, let's say like we scroll down, when we're satisfied, we're past the input, and then you basically, let's say, pass the input, and it did not throw an error, it threw a warning, and we basically gotta put here, I forgot to put here, LXML, for the beautiful soup that it's not freaking out. So as you can see, it prints out a bunch of dictionaries for a bunch of objects, and here are those OU guys. And what we're gonna wanna do is to use this beautiful library and say that like, the URL will actually equal to ast literal eval of the URL. Of URL, so that'll basically convert all that thing to a dictionary, and then we'll basically call the OU guy there. So there we have, like, that's the URL. We can append it here, our URLs that append the URL. So there we go, and then we can basically return the URL. No, we can return our URLs. What's wrong? What is wrong? Of course, our. So then we say URLs will equal that. Now let's go ahead and let's let's see what we've got here. Let's launch this thing. It takes some while for the browser to load, but don't worry, it's working. So let's give it some input. And there we go. I mean, it still printed the page, but here are like all the links. So let's say, for instance, like the third bus is, let's take like, I like actually this yellow guy. So let's this guy, let's count like 1, 2, 3, 4, 5, 6. Let's open this URL. And there we go. Here's the 6th bus. So okay, we got the URLs. Now all we have left is to, well, define something that will help us save all this stuff, right? So we'll say save images. I will take URLs. Okay guys, now let's define something that will help us save our images. So the first thing we're gonna say that it'll take URLs and it'll take directory. And directory is the variable that we'll specify here, which is basically how do we wanna call the folder where we'll put it all. Say like beautiful buses. Yo. Say the directory. So then we're gonna run a quick check of OS path is their directory. We'll say that if not, like if this directory does not exist, we'll say OS mk their directory. So now we'll have the directory where we can put all this beautiful stuff. Then we'll run a cycle for URL in URLs in actually enumerate URLs. Enumerate is basically gonna give us the index and the the value itself. So then what we want to do is what we're gonna do is to create a save path for each image, and save path will be os.path that join that directory and a formatted up to the 6th digit. Let me just check to make sure that I'm not wasting your time here and not making stupid mistakes, because no one likes them. and we'll format that with our index. So what that means to basically like the first link will be like 00001.jpg. Well, so that's our save path. Then we'll say try, because sometimes it fails. Most of the times like that, maybe like a fraction of a percent of the images fails, maybe like 1%. But for some reason, we don't want our program to crash because of them. So we'll say like, crash accept, and we'll call ulip.URL retrieve. And it takes URL, and then it takes the save path of where we want to put our thing. And if it's not, we'll say print I failed with URL. Now, and we're done. We're done, guys. So we'll just go save images. We'll pass here our URLs and directory, and let's launch the script and see what's gonna happen here. Because maybe like giant dragons will start flying out of my computer mouse, or maybe Google will start downloading the images. No one knows. No one knows. Anything could happen. Like, so we can like scroll down if we want, but it's not what we want here. So there we go. It prints out all the links, and now it should have started to download. So as you can see, it created the folder. And there we go, the images start to pop up here. There we go, there those beautiful guys are going. And now, oh my god, how I love this real quick Windows 10 image opening. But the point that I'm making here is that they're in high resolution, delivering like on your folder, like super in like the nice formatting names for us to use next. So that's it for images. And now I'm just gonna talk for 2 minutes real quick about the video. So okay guys, real quick on the software that I use to extract the frames from the videos. It's called Free Video to GPU Converter. Yep. And that's the one that my friend John recommended me, so thanks a lot, John, if you happen to be watching it, which I don't know if you will, but if you do, thank you. So basically download it, install it, like nothing complicated here. Once you have it, what it lets you do is that you can add several videos. For instance, I can go to my desktop, go to something like Yellow Stuff, Yellow Bus, where I kept all of my videos, and let's like select this guy here, and let's like, for instance, vid 1 and vid 2, and now we'll say, now here are a few options, and we can say like every 1 second, like whether we want to extract a frame per second or like every 15 frames. I chose every 15 frames because it's kind of more intuitive, I guess, and more useful. So, and I've selected the folder to be our training images video. So let's run this thing, so I'm convert. It's gonna be real quick. So again, like if you're, I don't know, detecting computer mouses, which you'll work with, but let's say that you do. You may wanna like go and basically record from all the angles your computer mouse to like help your model generalize. No, I did not do that. There we go. It'll create a bunch of images here per each frame, so you can see that it's kind of changed. I tried to kind of walk around and like basically run the bus from like all its sides and to get like the best shots that I could and don't get hit by it, because getting hit by a bus, I heard, is not the nicest thing in the world. So we'll handle the transporting of those images to the labeling. The labeling itself, I'm super excited for the labeling because I was able to basically customize an open labeling tool to get like the best labeling experience for me and for YOLO. So I'll share that, and hopefully you'll enjoy that, and hopefully you got something out of it. If you have questions, feel free to ask them. I'm like super excited to help and super glad. I wish you all the best, and I hope that you're having a fantastic day, guys. Just trying to share all the best stuff that I've learned in the best way that I can. So I wish you guys luck and perseverance, and bye, and I'll see you in the next one. Thank you for watching.